How's it going, everyone? My name is Yasa and I'm the head tutor at ACE Academy. Today we'll be covering questions 11 to 21 in the 2024 Maths Advanced HSC paper. Alright, so let's get started. Question 11. X equals negative 3, x equals 1, and x equals 5. These are the points that we're looking at, and what we're trying to find out is the first derivative and the second derivative. Easiest way to look at it is think of it as a roller coaster. So when I look at x equals negative 3, it's going upwards. Yep. So the first derivative has to be positive. Okay. Now, when we're looking at the second derivative, what I like to do is think of it as which branch is it part of. Okay, it's part of this branch, and that's concave down. So that has to be a negative second derivative. Alright. Let's look at x equals 1. X equals 1 is a inflection point. So the first derivative, if you had to take a tangent this way, it's horizontal, so it's going to be 0. And since it's a inflection point, it's going to have a 0 second derivative. Alright. Now let's look at x equals 5 again. Draw a little tangent. It's going upwards again. So it has to have a positive first derivative. And which branch is it part of? It's part of this branch, and that's concave up. So that has to be a positive second derivative. Alright. Let's move on to question 12 now. Question 12. Find the sum of the terms in the arithmetic series. Alright, so first let's define A. A is the first term. First term is 50. Let's get D, the difference. The difference between each of the terms is 7. And now let's use the formula. What are we trying to find? The sum. Okay, so for the sum we need the formula S equals n over 2 a plus l. A is the first term, L is the last term, and n is the number of terms there are. Okay, we don't know n, so we use another formula, and all of these formulas are in your formula sheet, so you don't have to worry about memorizing them. I do recommend knowing what they are, each of the terms. So D is difference, n is the number of terms, A is the first term, and L is the last term. So let's use this formula. That's the number of terms formula. Okay, so the Tn stands for the nth term. Okay, so we're trying to find the last term because we're trying to include all of the terms in the series. So let's use 2024. That's the last term. A is 50 plus n minus 1 times 7. N equals 283. Now do we have n? Plug it into this formula. That's your answer. So let's move on to question 13. And so it gives us a graph and the population modeled by those equations at the top here. Let's see what it's asking for. So population in 1985. That's pretty much the starting population because number of years since 1985 is 0. So B equals, so A. So if you look at population W and K, this one is gonna grow because it has a number greater than 1. This one's gonna shrink because it's a number less than 1. Okay. So now let's have a look at A equals 34. A equals 34 is this. So this one has to be population W. This one has to be population K. All right. So let's look at K. It's going to be about, okay, so 60, 70, 80, 90, 100. So it's going to be 280. Just reading it off here. That's going to be 280. Percentage yearly change. The yearly change, the way you would calculate this is, okay, so X is the amount of years that passed, okay? So each year, so if you were to just take population W, for example, A is the starting population, and it's going to be multiplied by, let's say year 1, it's going to be multiplied by 1.055. So if you think about it, A times 1, it's going to stay the same. It's going to go to A. If you do A times, let's say 1.5, it's going to go to 1.5 of A, and then second year, let's say 1.5 squared, it's going to go to 1.5 of that. Okay, so 1.5 of this. So what I'm trying to say is the yearly percent increase depends on what the number is here. Okay, so if you were to take 1.055 minus 1, it's going to be 0.055. that's as a decimal, and as a percent it's going to be, let's see, 5.5%, because I'm just moving the decimal point. So that's going to be for W. Okay, so for B, let's use the same analogy. So if B times 1 stays at B, that means anything less than 1, it's going to decrease. Okay, so let's take 1 minus 0.97, that's going to be 0.03, but as a percent it's going to be 3% if you have to move the decimal point. Okay, and this one's going to be negative. Why? Because it's decreasing. If you look at the function for population K, it's going down, so it has to be negative 3%. Awesome. Alright, so now let's have a look at predicted population when x equals 50. Use the actual function for W. Y equals A is 34 times 1.055 to the power of 50. Just plug it in, and you should get about 494. Yeah, so 494, rounding it off to the nearest whole number. Okay, so question 14, the curves, there's two curves and you have to find the area in the middle. For the first question, you're asked to find the x coordinates only. So first let's equate them. Okay, when you equate them, you'd find wherever they're equal, so you'd find wherever they touch right here and right here. Okay, so x minus 1 whole squared equals 5 minus x squared. That x has to be 2 or x has to be negative 4. Alright, it only asks for the x coordinates, so you don't have to find the corresponding y coordinates. So that's your answer. Awesome. So now we have to look at the area enclosed by the two curves. We have the x coordinates, so it starts from negative 1, ends at 2. So let's set up our integral. So it's going to be a equals area, the integral from negative 1 to 2. Now what you want to do is to find the area enclosed between them. You have to do top curve minus bottom curve. Let me quickly explain why this works. So if I were to draw it out again, this is the top curve and this is the bottom curve. I just zoomed in, pretend I zoomed in a lot for you guys. Yeah, so if you take the top curve from negative 1 to 2, you're taking this area. Okay, now if you were to take the area, let me get another color. If you take the area of the bottom curve, where's my, yep, if you take the area of the bottom curve, you're gonna take this area. Okay, and that's why you're minusing them to find this area in the middle. Yep. Alright, so now let's get on to calculating it. So the top curve is gonna be 5 minus x squared, because that's concave down, so it has to be negative x squared. So 5 minus x squared minus x minus 1 whole squared dx. Okay, so let's do our calculations. So what I like to do is on the side, somewhere on the side, I like to calculate what this is individually. So now all I have to do is put that in here. So 4 minus 2x squared plus 2x dx. Alright, so now let's integrate 4x minus 2 on 3x cubed plus x squared, and then they go from from negative 1 to 2. So now you have to plug in those values, and if you had to put this into your calculator, you should get 9. Alright, that's your answer. Question 15 talks about water in a tank. This is a rate of change type of question. So now what you're trying to find is the volume of the water in the tank when the change of volume equals 0. Okay, so first let's see, what's the volume in the tank first. To find the volume in the tank, you have to integrate, okay, with respect to t. Okay, so if you had to rearrange everything, 300 minus 7.5 t dt, with respect to time, you're gonna integrate. So if you had to integrate dv you're just gonna get v. Okay, so you're gonna have to integrate 300 minus 7.5 t with respect to time. 300 t minus what's 7.5 divided by 2? That'd be 3.75 t squared plus c. To find this plus c, what you want to do is at t equals 0, v equals 350. How did I figure that out? Initially, that means t equals 0, there is 350 liters. Okay, when you see the question gives you information like that, what I like to do is just write them down in a mathematical manner, nice and concise. So now you can just plug this in. 350 equals, plug in t equals 0, so this one's going to be 0 minus 0 plus c, so c has to be 350. So now that we have the equation for the volume, we have to figure out on the side, I'm going to do this on the side, dv over dt equals 0. When does that happen? Okay, so t equals what? This is easy. All you have to do is plug it into here. 0 equals 300 minus 7.5 t, rearrange, equals 300, and then t, if you have to divide it out, it has to be 40. Okay, so now at t equals 40, t equals 40, what is v? Okay, all you have to do is plug it in. You get 6350 liters. Awesome. Okay, so question 16 is a bit more theoretical. It's asking to compare the two data set. It's asking to examine the skewness and the measures of central tendency and spread. Okay, so skewness is very important. Okay, skew, you have to talk about the skew. So let's talk about the skew right now. Let's look at garden A, garden B. Garden A is going to be negatively skewed. Okay, so most of the data, it's going to look something like this. Okay, and this one's going to look like garden B is going to look like this. Okay, the IQR of the box and whisker plot shows you where 50% of the data is. That's how I'm able to sketch something like this and something like this. Okay, because in my head this box represents 50% of the data. So this is just a rough sketch. So now I can conclude that A is negatively skewed, is positively skewed. Alright, awesome. So now let's talk about the measures of central tendency. Okay, so what does this mean? Using the data here, the central tendency they're talking about is the median. Okay, so let's compare the median. The median is obviously higher for A than B. So median, I'm going to write them down as dot points, but you guys have to write them down as sentences here. So median, A has a greater median than B. And now let's talk about the spread. Spread is talking about the range. So you can either talk about the IQR, the interquartile range, or the actual range of the data set. Okay, so even if you talk about IQR or the range, both of them are measures of spread. For the IQR, if you look at A and B, A is obviously greater than B, and also the range A is greater than B. Question 17 is asking to sketch the graph of VT first. Okay, what's this graph? Okay, it's an exponential graph. So any type of exponential, it's going to go look like this. So it has a negative near the x. So it's to do with the time. Okay, so instead of x, I'm going to write t. So it's easier. Okay, k is just a constant, as we see here. If you're to add a negative to the t, it's going to flip on the y-axis. Okay, so it's going to look like this. Okay, now if you had to add the negative in front of the function, it's going to flip on the x-axis, so it's going to look like this. Okay, so that's the basic gist of the function. Now the 1 minus e to the negative kt, what does that suggest? Okay, it's going to shift it up 1. Okay, so the 1 is just a shifting thing, so 1 is just going to shift it up by 1 unit, and everything is in the bracket, and there's a 6.5, so that's just a scaling factor. Okay, so what this is going to look like is it's going to plateau out here. Okay, if you had to see this function here, it's going to plateau at exactly 6.5. So that's so let's say there, and it's going to be 6.5 because that's the scaling factor. And write your v, t, you can write your 0, and there we go. There's a quick sketch. Okay, so now let's move on to question B. When t equals 1, so like I said before, write your data like this. The voltage is going to be 2.6. Find the value of k. Right. So now plug in t equals 1 and v equals 2.6 to the equation. So 2.6 equals k equals negative ln of 0.6 and 3 decimal place, so that's going to be approximately 0.5113 dB. Awesome. Now that we found k, let's move on to question C. So t equals 2. When you see the word rate, you have to think about the change, so dv on dt. Alright, so first let's differentiate. So dv on dt. So when you differentiate this, the negative t is going to cancel the negative here, so the k comes down as well. So 6.5 k e to the negative kt. Okay, that's the equation for the rate of change. So now at t equals 2, what is dv on dt? Okay, just plug it in. One thing I want to point out is over here, when you're subbing in k, okay, when you're subbing in k, the reason why I use this is because we got the value from the previous question here. But if they didn't ask for the value in the previous question, I would use the exact value. So that would be k equals negative ln 0.6. If this was a different question, I would use the exact value. But for this, since they already asked for the value of k, they're going to consider a rounding error and stuff like that. Okay, so now that's going to be 1.195. The units is going to be volts per second. You can see here, so V over S. T is in seconds, V is volts. There we go. Question 18 asks, what's the probability that this player does not score a goal in the first 2 attempts? Okay, so let's find the probability that he doesn't. Failure is going to be 1 minus 0.15. It's going to be 0.85. And if he does not score a goal twice, so it's going to be a double fail. Okay, so the probability of double fail, so 2x fail, it's going to be 0.85 squared, or you could write it as 0.85 times 0.85. The reason why I wrote it like this is because if you look here, in my head, this is what's going on. So there's a fail and then there's a goal. There's a fail, goal, fail, goal. So I'm just following this branch. That's why I'm doing 0.85 times 0.85, which is going to be 0.7225. Awesome. So now let's move on to part B. Scoring, probability of scoring at least 1 goal is greater than 0.8. Okay, what does this look like? So at least 1 goal is, so if you think about it, at least 1 goal is going to be 1 minus all of every attempt being a failure. So if you have let's look at the tree diagram again here. First attempt, second attempt, third attempt, and then it keeps going down. Okay, so all attempts being a failure, so I'm going to call each attempt, so 1, 2, 3, all the way up to n. Okay, so all n attempts as a fail. Okay, because that's the complementary of at least 1 goal. Okay, so what's this going to look like? So 1 minus, so each time you fail, what's the probability going to look like here? So we've already calculated that if you fail twice, it's going to be 0.85 squared. Okay, if you have to fail 3 times, it's going to be 0.85 cubed. So if you have to fail n times, it's going to be 0.85 to the power of n. So now this probability has to be greater than 0.8. Okay, so now what you want to do is 0.2 is greater than 0.85 n. 0.85 n is less than 0.2. So you take the ln on both sides, so n ln 0.85 less than ln 0.2, Now the trick here is n is going to be greater now when I divide it out, ln 0.2 divided by ln 0.85, because if you had to put this in your calculator, it's a negative number, yeah? Okay, so now if you had to plug this in your calculator, you get n is greater than 9.9. So therefore, you need at least 10 attempts for the probability of scoring at least one goal to be greater than 0.8. Moving on to question 19, we're given the curve x to the 4 minus 2x cubed plus 2. Write down our function. Let's differentiate it. Okay, 4x cubed minus 6x squared to become 0, and then differentiate it again. Okay, so 12x squared minus 12x. Awesome. So first, let's find the stationary points. How do you find the stationary points? You set y dash to 0. So factorize, and you could solve it as well. So let me take out a 2x squared. This one 2x. This one become 3. Yep. And now I can say x equals 0, and then this one would be x equals 3 over 2. Okay, so at x equals 0 and x equals 3 over 2, there's going to be stationary points. So now to check the nature of the stationary points, what I like to do is get a table and check the values on each side. Okay, so I'm going to do that all in one table. So now let's check for y dash. So if you plug in -1 to y dash, it's going to be -10. 0 is going to be 0. 3 over 2 is 0, like we calculated. 1, it's going to be -2, and then 2 is going to be 8. So what did I just do here? Okay, so let's visualize this. What I like to do is at the bottom, I like to do something like this. It's going to be negative and then 0, because this, we're talking about the tangents here. Okay, when we're talking about y dash, we're talking about the tangents. So -2 is going to look like this, and then 0, and then 8 is going to look like that. Okay, whatever's positive, it's pointing up. Whatever's negative, it's pointing downwards. Okay, so now let's take a look at the points of inflection. Okay, y double dash equals 0. So 12x squared minus 12x equals 0. Take out a 12x, x minus 1, x equals 0. We already found x equals 0 here as well. This and this. And if you have to look at x equals 0 here on the table, what can we see? We already found out that it's going to be a point of inflection, because if you have to follow this, it's going to look something like that. Okay, so that we already know that's going to be a point of inflection, and this is just a double check as well. So now we also need to test x equals 1. So what you want to do is, you can do the same thing I did before with the table. If you plug in -1 to y dash dash, it's going to be 24. Plug in half, it's going to be -3, and plug in 3 on 2, it's going to be 9. Okay, so 0, it's gonna, I'm gonna dash them out. Okay, so 24, what does that mean? If y double dash is 24, that means it's going to be concave up, because it's a positive number. -3, it's negative, so it's concave down, and 9 is concave up. Okay, this is talking about concavity, and that's how we're checking the nature, like it's asking for. Alright, so now let's get to the sketching. So at x equals 0, we know it's going to look something like this. Okay, so at x equals 0, it's going to look something like that. So x equals 1, I'm just going to put a dot there for now. Okay, so now let's look at 3 over 2. 3 over 2 is a stationary point where it's going to go something like this. Okay, and we already know that at x equals 0, it's going to look something like this. Okay, so let's just join them up. This is another inflection point as well, and there we go, and there we go. So now what you want to add is the points, and you also have to show any x and y intercepts as well. So at x equals 0, this is going to be 2, so that's 2. Over here at x equals 1, it's going to be 1, and at 3 over 2, I'm going to do 3 over 2, it's going to be 5 on 16. Okay, and there we go, that's my sketch. Okay, let's look at question 20. Question 20 looks pretty scary because of 3D trig, but let's walk you through how to do it really easily. Alright, so if you look at AC, let's just look at this triangle. In 3D trig, I always like to split everything into individual triangles. So if you look at this triangle, C, T, and A, this is 40, and they're asking for AC. Pretty simple question, if you ask me, because this has to do with tan. So tan is O over A, opposite of adjacent. So all you have to do is tan 35 degrees is what's opposite? 40 over AC. And now AC is going to be 40 over tan 35 degrees. Okay, which is going to be approximately 57.13, and you can write hence shown or something. Okay, let's move on to part B. Find the bearing of B from C. So let's say C is here, A is due east. Okay, so if you have to do that, that's 90 degrees. A is due east. B we don't know, but we know the distance between A and B. Okay, so let's say this is B, and that's 100 meters. What we're trying to figure out is the bearing of B from C. So if you have to draw a little bearing sign here, we're trying to find what's this angle. Okay, so that's just going to be 90 plus whatever this angle is. Yeah, so what you want to do is use the cosine formula, because you can get this side. We know this side AC is already 57.13, and we just have to find BC with a similar method here. So let's draw the other triangle for T, C, and B. 30 degrees, 40, and it's the same formula as well. So BC is gonna be, so let me just do 10, 30 equals O over A, so adjacent BC. So BC is going to be 40 over 10, 30, which is approximately 69.282. I'm going to do it to 3 dp, and I'm also going to write AC equals 57.126. I'm going to use 3 dp for more precision. Alright, so now write the formula, the cosine formula. Angle C is going to be cos inverse of A squared plus B squared minus C squared over 2AB. Now you're probably wondering what's A, B, and C. What I like to think about is this sandwich. Okay, so same triangle. Okay, this is 100, A, B, and C, and this is angle C. Angle C is always going to be sandwiched between A and B. Okay, and then this one is going to be C. That's what I like to think about. It's going to be sandwiched in the middle over here. Okay, so A is going to be BC, and then B is going to be AC. Okay, so all you have to do is plug in the plug it into the formula, and you get approximately, you get 104.127 blah blah blah. It says to the nearest degree, so I'm going to take 2 dp over here. Yeah, 104.13 degrees. And now we're not done yet, because the bearing, if you have to look at it again, from C, it's going to be A is here, C is here, and B is like somewhere here. Okay, you're going to take, we only found this angle, so now we have to add it with 90 degrees to find the total bearing. Okay, so now the bearing, that's going to be 194 degrees to the nearest degree. Question 21 is fairly simple. You just have to know your theory and how to analyze data. So it's asking for 3 observations about anacondas that may be made from the scatter plot. No calculation, so you just have to go off the graph. Okay, and one thing to note here is they also gave us the anaconda's age of maturity, so we might want to include that in the answer as well. First thing you can see is also white is female, black is male. So first thing you can see that every time the white square is bigger than the black circle. What does that mean? That means female anacondas are longer than male anacondas. Now, what else can you say? Let's see how fast they grow. Okay, so if you have to think about, let's say pink is the female, so, and blue is the male. How fast are they growing? You can clearly see that the female anacondas grow faster than males, so that's another observation. And also, let's look at the age of maturity. That's 4. Okay, age of maturity, you can comment something like that. Do they grow after that? So yep, they do grow after that, and over here they also grow after that as well. So both anacondas grow after age of maturity, which is 4 years. Okay, and that's question 21. Alright, so that's going to be it for questions 11 to 21. In the next video, I'm going to cover questions 21 to the end of the paper as well, so stay tuned for that. And be sure to subscribe and turn on notifications so you know when it's going to come out. And if you guys need further help with any math questions, be sure to check out Ace Academy, and the links for contacting them would be in the description below. Thank you and have a great day.